Well, we're studying inductive reasoning and conjecture. And inductive reasoning is with something that we might use if we're looking and studying a pattern, as an example. And we assume and we recognize that there may be a pattern that exists. And then we assume that that pattern is going to continue. Well, then we are applying a concept that we would call inductive reasoning. It means that we're looking at several examples and we're coming to a conclusion. And from that, then we can make a statement using inductive reasoning that we would call a conjecture. This is a concluding statement based upon inductive reasoning. And a little later on, we'll talk about counterexamples. That might be an example that might prove conjecture false. But right now, we're going to be looking at, been given some algebraic or geometric conjectures, statements that are conjectures. I guess I should say that we're given some statements and we're to use inductive reasoning to make a conjecture. So let's take a look at what we're talking about here. Let's look at this first one, where we have a statement concerning the sum of two even numbers. And so what we may need to do, and what we do need to do, is actually create some examples and see if we can't make a conjecture. So if we're talking about the sum of two even numbers, let's see, well, what if I did this? 2 plus 4, those are two even numbers. That equals 6. And 4 plus 6, two even numbers again, equals 10. And then let's say 6 plus 8 equals 14. So I've added two even numbers. And the pattern that I can see here is that when I do that, every number, the sum of those numbers are also all even numbers. And so I can make a conjecture that the sum of two even numbers is going to equal an even number. So I take this statement, I provide some examples, and then using inductive reasoning, I make a conjecture. Let's look at the second one here. The relationship between AB and EF. Now, we don't know what that is. That might be a line. It might be an angle. That would be the type of things that we're going to look at and study in geometry. But it says the relationship between AB and EF, if AB equals CD and CD equals EF. Well, if AB equals CD and CD equals EF, then we could make a conjecture, and we could draw this. We could have little lines and draw it. I'm not going to do it on this for lack of space here, but one of the ways you can make a conjecture is with a drawing. But just verbally looking at this is if AB equals CD and then CD equals EF, well, AB must equal EF. And then let's look at this third one, the sum of two consecutive natural numbers. So again, I'm going to do some examples. Natural numbers, 1, 2, 3, 4. Let's see, now this is actually the sum of the squares of two natural numbers. Sum of the squares of two natural numbers. Well, let's see. 1 squared plus 2 squared equals, well, 1 squared is 1. 2 squared is 4. That equals 5. Let's say 2 squared plus 3 squared. Well, 2 squared again is 4. 3 squared is 9. 4 and 9 is 13. How about then 3 squared plus 4 squared? Well, 3 squared is 9, 4 squared is 16, 4 times 4 is 16. That equals 25. So there's 3 examples. So if I'm taking the sum of the squares of 2 natural numbers, one thing I can see in this pattern is that the sum of these squares are all odd numbers. And so I might make a conjecture then that the sum of the squares, and we were using consecutive natural numbers, sum of the squares of 2 natural consecutive numbers will be an odd number. I'm running out of space. I'm going to abbreviate number. Okay. Well, there we go. We've taken those are some examples. This corresponded to page 92 in your textbook on example 2, where we took some statements, provided some examples, and made a conjecture.